Hello friends, this is day 8 of doing Codeforces until I become specialist, and today we are start from 21st problem of TLG CP sheet. So the first one is blank space. So let us read the question. You are given a binary array A of n elements. So a binary array is an array consisting of only zeros and ones. We already know that binary means there are only two numbers, which is two digits. One is zero and another one is one. And we have an array whose length is n, which is binary array, and that n has to be a length of that binary array. A blank space is a segment of consecutive elements consisting of only zeros. And here blank space, it consists a blank space and it contains only consecutive digits. So a blank space is a segment, is like a part of the array, so which is a consecutive part which consists of only zeros. Okay, it contains only zeros. Our task is to find the length of that longest blank space. Okay. Okay, here three number of test cases. For each test cases, we have to take n and we have to take the elements into the array A, which is binary array. Okay, for each test case, output a single integer, the length of the longest black space. So let us see these questions. Here, the longest zeros which are consecutively appeared here is only 2, and here it is 1. See, right? And here it is 0. Okay, only 1 is appeared, so that is for third one the answer is 1. And for this there is no 0, so that's why the answer is 0. And here three consecutive zeros are there, so here that's why here it is 0. Okay, we have to just iterate over the array, and whenever we are getting 0, we have to increment our current 0 value. After that until from that when we are getting 1, we have to we have to make that current 0 value is equal to 0, but before that we have to arrange that current sum into the maximum 0, like which is actually a global variable here. I think you understand this the intuition. So let us solve this question. Let's write code for it. So for that, I'm opening Codechef C++ online editor and a compiler. Come on. Okay, what we have to do? We have to read the number of test cases. Okay, and for each test case, we have to read the size of the array, and and for each that number of size, we have to declare an array with that size. Okay, after that if you are declaring the array, we have to read data into that array, right? So I'm just reading data into my array, so which are probably only zeros or ones, as it is a binary array. Okay, so from here onwards, when we are getting 0, like we have to iterate the array, right? So we have to iterate the array, and let us say this is a global variable which actually stores how many zeros. So go, like not a go, how can I say max zeros, max number of zeros. That's what we have to do. I say that that is equal to 0. I'm saying that is equal to 0. Okay, so here we have to check if the array element is actually a 0. So then what we have to do? But before that, we have to take the current max, which is absolutely 0. Okay, so if it is 0, when it runs again, it actually goes to 0 again. So what we have to do? We have to initialize this current matrix outside of the loop. just as maximum matrix. So current matrix of 0 is also 0. So we have to include the current max of 0, cm is equal to 0 when we are getting 0, right? And when we are getting 1, what we have to do? So we have to shift the max value, shift that current max value into the max of 0 value, so which is max of 0 and uh, current max value, and we have to make current max value is equal to 0. That's enough. Finally, we have to print the max of zeros along with end element, so which goes to the next line. This end element actually makes uh, like goes to the new line after performing the current operation. Like after printing the value of current max, it the controller goes to the new line unless it presents in the same line and wait for the user input, right? So let us see here. We are getting 21003, 21003, 211003. So for this, it actually prints 0. Why? Why it actually prints 0 here? So here it thought, okay, it's 0, so current max is actually incremented. Current max is equal to 1. Okay, and so when it goes to the next index element, it moves to the next index element. Current max, as it is not equal to 0, so we have to go to else spot, and the max of 0 is actually 0, and current max here it is equal to 1, as it is already incremented. You have to assign that into current max, and current max is equal to 0 from there. Okay, so 0. Oh, but we have to assign maximum, right? Current max is equal to 0. So 0 and max of 0. Max of 0 is already what? 1. So as because that is actually the max of 0 there. Okay. Then why we are getting 1 here? I don't understand why we are getting 1 for this test case. So less than 4, 0, 1, 2, 3 indexes. So for 0 index, okay, we have to check. Okay, a of 0 is actually a 0 value 0. So that's why I'm incrementing the current max value. Current max is equal to 0. So current max is equal to current max plus 0 plus 1 is equal. So 0 plus, is equal to 1. Current max is equal to current max is plus 1. It's incremented to 1. Okay. And after this, it's go to increment the I value, which is 1, and 1 less than and length of that array, so which is 4, 1 less than 4. So right, so but here the value is 1. So max of 0 is actually equal to max of 0 comma current max. Here current max is already equal to 1. Okay, so 1 comma 0, which is greater 1. So max 1 is greater, so it assigned to that max of 0. And uh, so now current max is actually equal to 0. From there, current max is actually equal to 0. Okay, and it incremented 1. So current max is not incremented 1 comma 0 1, 1 comma 0 1. Okay, everything is right. And we have to, after iteration is completed, we have to print the current max of 0 value, right? Wow. Why we are getting one? Let's do one thing here. What if it change the line there? We have to increment our max value when we are getting 1 only. Like when we are getting 0 only, we have to increment our max of zeros. Okay. This it will actually gives the output. Okay. So for previous condition, we are actually incrementing the max of zero value when we are not getting zero. But when we are getting zero, the current max of zero is actually changes. So in that situation, we have to increment our max. But previous condition is also right in some test cases. Like we seen that previous test cases. Okay, max value and max of zero current max. Okay, here we don't need to actually. We can also use for each statement here. There's no problem with that. Let's submit this. Come on, come on. 3, 2, 1. Boom. Accepted. And then let's move on to the another question, which is coins. Okay. In Bedland, there are two types of coins having denominations of 2 and k Burleys. Your task is to determine whether it is possible to represent n Burleys in coins. Okay, we have to represent n Burleys in coins. Like that, we have to represent n number of rupees with coins. As a similar question. So that is whether there exist non-negative integers x comma y such that 2 into x plus k into y is actually equal to n. So for each test case, print as if it is possible to represent n Burleys. Otherwise, we have to print no. So okay, I got this question already. So simple. It is simple one. Uh, we have to check. So let us open the paint. So what he is saying, n and k. Okay. So here the n value is actually equal to 5 and the k value is actually 3. Okay, we have to represent the n value with the coins, and the coins is like start from 2 into x plus k into y. We don't know this y. We have to check whether it is equal to n or not. If it is equal to n, we have to return s. If it is not equal to n, we have to return no. So have the k value also. So in this question, the k value is actually the 3. So we don't know the value of x and the value of y. But we have an equation 2x plus 3y is actually equal to n. If it is equal to n, we should return n. True? Otherwise, like we should return s. We have to print s. Otherwise, we have to print no. Like, so how can you judge? We should able to get n value here or not. So here 2, here 3, and here n. So what is an value? N value is an odd value. So 5 is an odd, right? And 3 is an also odd, but 2 is an even number. So as odd, both matches, you have to print s. Actually, actually that's not the case here. Um, how can I say? Let us take the integers like x is equal to 1 and y is equal to 1. So here e into 1, which is nothing but 2 into 1, 2, and 3 into 1, 3, which is actually equal to 5, right? This condition is true. So we are able to do we are able to do present the n value into the coins, right? Into the coins 2 into k coins. So as we are achieving this. Why we are achieving this? If let us take the k value is actually the 4. So in that way, so 4 1 is 4. So 2 plus 4, which is actually 6. 6 is not equal to 5, right? So it actually depends upon the odd value on the even value. Like so the test case 7 and 4. The text case 6, 1 and 1. Here k value is equal to 1 and n value is equal to 6. And the equation is 2 into what is the value of x. So that is an imaginary value x plus k, which is actually 1, into y is equal to 6 or not. So as 6 is an even number, and we should easily represent the even number with the odd or even numbers. Like here 1 is odd and 2 is 1. 2, 3 is actually 6. If you take x is equal to 3, we can get more than 6 values. So we have to take it, here it is a 2. So 2 twos, so the value becomes 4 here. And so if y is 2, then only 1 into 2, 2 becomes. So these y 4 plus 2, which is actually equal to 6, right? Okay. So what we have observed up to now. So whenever the n value is actually equal to even, it won't bother about the value of k, whether it is x or whether it is even or whether it is odd here, right? So we can get the answer yes. But whenever it is odd, so for odd, when n value is odd, if the k value is odd, then only we have to represent the s value. Why? See here in this test case, the n value is odd and k value is also odd. That's why it is accepted, right? Otherwise, if it is even, then we should return no. We are already have this types of test case when n value is odd and the k value is even. So we have to print what? We have to print no. So that's why here no is the answer. Okay, we just have to write a code for this institution. That is enough. Okay, I think you understand the code. So let's implement code for it. So we have to read two values, one in one and one on another one is k. Okay. So every time we have to check if the n value is actually the even or odd. If n value is even, so what we have to do? We have to print s without even second. Okay, got it? Otherwise, so like n is actually not an even number. It is an odd number. So we have to check its k value. If the k value is actually the odd, so that means odd means even means. So k value is actually even, then we should print no for this, right? Otherwise, we should print s. Let's copy these test cases and paste it here. And the answer is like 2s, 1o and 1s. 2s, 1o and 1s. So that's easy. Okay, let's submit it. Here, I'm I'm getting here another point. Let me share that with you. So if an odd number is multiplied with the odd number or even number, we can get the odd number and the even number. But but oh, sorry, wrong answer on test 3. Why it gives wrong answer? Let's go and check. Uh, Once read the code again. Okay, we have to represent. There are two types of coins having denominations 2 and k berlin. Okay, the denominations are like 2 and k. So our task is to determine whether it is possible to represent the n berlins in coins. Okay, whether there exists non-negative integer x it has to be non-negative integer. That means a positive integer. So 0 is also a positive integer, right? And by such that 2x plus ky is actually equal to 1 when it equal to 1, you have to print as, otherwise you have to know. Okay. Here k is not equal to 1. The only line of each test case consisting two integers n and k, and k should not be equal to 2. We forgot to use that condition. So k is not equal to 2. K is not equal to 0 and k is also not equal to 2. Okay, let's add this and submit the code again. Let us see whether it is accepted or rejected. Oh, okay, here. You just have to add that line. Okay, whenever k is also not equal to 2. See here, k is not equal to 0. Okay, let's see here, running on test case 1. Okay, again here, wrong. We are actually missing something from there. I mean, something from here. What is it actually? Is it size? And 10 to the power of 18. Yeah, 10 to the power of 18, bro. Okay, I guess we should not use int there. We have to use long. Okay, let's submit it. Come on. Thank you. Thank you, bro. Oh, what is this? It is not submitted. Come on. Are you going to submit or not? So maybe k is not equal to 2, even though k is an even number. Even though k is an even number, it shouldn't be equal to 2. You have submitted exactly the same code before. And what is the result? I need the result. Accepted or rejected? Submission is compare, judge, invalid. Okay, I don't know. We stop responding. We submit form, cancel. Let's go back. Just what else I am missing here? What is that I am missing here? We are reading n value and k value. Okay, and when the n is odd, like when the n is actually even, so we have to take print s, and if that n is actually not an even, then we have to see whether the k is actually equal to 0. Whenever k is odd, whenever k is even, k is odd, then only it will accept it, right? So for k is actually the even, you don't need to use this test case. When it is even, then it is no. Okay, wait. So you can also write code like so if this is existed, uh, okay. If this is not existed, it comes to the second line and it checks whether actually k is actually even. When the k is actually even, we have to print no. We need k is actually odd. Okay. So I think let's submit this. Oh my god. The previous code is actually not submitted. It's running on test case 9. It's taking too much time. Let's try to solve another one. Walking monster. So Yan oh, is standing on the infinite plane with the Cartesian coordinate systems on it. In one move, she can move to the diagonally adjacent point to the top right or the adjacent point to the left. So the like walking master. So the master is able to move to the diagonally adjacent point on the top right. So on the top right. So top right, it move to the adjacent point on the top right and adjacent point on the left. Okay, so that is if she stands at a point x comma 0, she can either move to point x plus y and y plus 1, or she can move like x minus y. Here x minus y. So go back to the previous and uh, y, but same column, right? Same column, but goes to the top. Uh, uh, sh- uh, Top right, adjacent point to the top right or adjacent point to the left, okay, a top or left, okay, in this way. Top, this is the robot and it can move from top, it can move to the top or to the left. So the master initially stands at a point a comma b and wants to move to the point c comma d. So he wants to move from a comma b to the c comma d. Find the minimum number of moves she needed to make the clear that it is possible. Okay, if what if it is not possible? You have to print -1, and the test case is set under the power of minus a to the other power of 8. Whether it is accepted or submitted, let me check it again. Okay, it is accepted. So the previous code is actually accepted, and we just changed the code, right? So I think it is also accepted. Yes, we can represent the given and value in the current denomination, right? So now let's come to the this question. Here he just asked us whether uh, the master can able to move from a comma b point to c comma d point. If it is S, we have to represent how many minimum number of moves he needed to transport to the point C comma D. If it is not, we have to remove, we have to print -1. Okay, let's observe the test cases. Here he is at a point -1 comma 0 and he wants to go to the point -1 comma 2. Okay, and we have initially condition like at a point x comma 0, the you like the master can able to move to the top of the point. That means x minus y comma like x minus 1 comma y. So he can move to the top or left, bottom left. So x plus 1 comma y plus 1. Here it is equal to 0 comma minus 1 plus 1, 0 comma 1. So 0 comma 1, which is not the destination, but in minus 1 comma 0. The result for this like minus when we go to the top x minus y, right? So now it is also changes. We don't get this. Okay, we definitely have to use four operations. Seems it like it. So let's check it. So this is a graph, and zero. This is zero, and this is one, which is minus, and this is minus two, and here one minus two, and okay here minus one minus two, here one two. Okay, he is at a point minus 1 comma 0, so that is here. I'm exactly, the robot is exactly here, and he wants to move to the point minus 1 comma 2. So minus 1 comma 2, so he wants to move to the point here, and we have a condition. What is that condition? Let's check that condition. So um, for the point x comma y, he can able to move to the point x plus 1 comma y plus 1, or x minus 1 comma y. So for minus 1 comma 0, for minus 1 comma 0, when we perform this operation x plus 1 y plus 1, the result is like x plus 1. Okay, when we add 1 to it, so here minus 1 and plus 1 0, and here 0 0 plus 1 is actually equal to 0. So when we add, and when we subtract minus 1 minus 1, which is actually minus 2 comma, and y is actually 0, so it stays at 0. Okay, now we are actually performing one operation. So for the second operation, what if it uses x plus 1 comma y plus 1, then it becomes like 1, and here it comes 2, 1 comma 2. Now 0 comma 1 is here, and 1 comma 2 is 1 comma 2, so here. But I want to move from minus 1 comma 2, like that is my destination. So what we can do, wait, y for bottom x plus 1 comma y plus 1 comma y plus 1. So here you can either move to the top or to the bottom, like minus 1 plus 1 is actually 0, and 0, so the same point here only, right? So but for this point it will changes, because there is no like there is a 0, there is no 0 from this point 1 comma 2. That's where we are now, and we have to move to the minus 1 comma 2. So but for this, when we perform the operation x plus 1, so here uh, 2 comma 3, which makes no sense, so we have to just x minus 1, so 0 comma 2. So here number of times performing operation 1, and not to get this number of times performing operation 2, not to get this number of times performing operation 3, and we have to perform it operation again, because it is not actually equal to our answer. Our answer is actually equal to minus 1 comma 2, so here 0 comma 2, so we have to perform the operation again, which is x minus 1 comma y. So here that is we can get result like minus 1 comma 2, which is matched at our results. So that is number of times we are performing the operation is actually 4. See here. So here it is also actually equal to 4. Okay, let's go to the another test case. So, so 0 0 0. So 0 0 4, 5. So in order to meet the point 0, 0 from 4, 5, how many steps we have to require? So like this is a number line and this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And here also let me take the numbers like 1, 2, 3, 4, 4, 5, up to what? Up to 8. Up to 8. So I think that's enough for here. Up to 8, not only 8 to 9. Wait, wait, wait. Let me arrange all this. I need space 1, 2. And here 8 and 9. Okay, 9. Okay, so we are currently stayed here 0 comma 0 at point 0 comma 0 we are actually stayed there, and we have to move to the point 4 comma 5. So here 4 and here must be a point 1. So here we have to move to the point over here. Okay, how can we move to the point from 0 comma 0? One step, we have to directly go to the top. So that's why like x comma x plus y comma x plus 1 comma y plus 1. That's what we can do. So it will go to the top. If you do x plus 1 comma y comma. If we can do x minus y 1 comma y, so we can just move to the left or its right. That's what we are observing, right? So it can only move to the left or right. But it can also move to the top. Only the top, not the bottom. Only the top. Okay. So what is the top value that it can reach the maximum? It's simply depending upon the y2 value. So like from 0 comma 0 to first we have to go to the point 5 comma 5. So because that is the highest point, so it can go to the 5 comma 5. Okay, but now we are actually here and it can take only, not actually only. How can we say that this number of operations is required? Simply, we have to do 5 minus 0. So here it takes 5 operations. Got it? So first x plus 1, x plus 1, x plus 1, x plus 1. So then we can, okay, it takes 5 operations. And the point is like a 5 comma 5. But we need point 4 comma 5. So we need point like 4 comma 5. So here, uh, uh, so from here we can move to the left or we can move to the right. So how can we move to the left? Think about it. How can we move to the left by subtracting this x value? So how can you get the x value? You are not actually changing the x value. So we have to change the x value also. X value becomes how much more? The difference of y difference. So which is actually 25 plus the x value. So which is equal to here 5. So okay. Well, now we have y difference. So exactly this is the y2 value, right? So how many operations does I need to take from which to the x1 to x2? Simply we have to difference it. X difference here, which is equal to y2 minus y1. So here y2 is actually minus, right? So y1 is actually stronger. So I think we have to do y1 minus y2. Then only it will work. Like y1 is actually equal to 5 minus y2 is actually equal to 4. 5 minus 4, 1. So here this total 1 plus 2, total how many steps? 6 steps. So here that's why here 6 is available. Okay. Like this is one of the way we can get some solution in simple way. We have to directly reach like we actually we have to use for loop while loop in this while loop in this condition because we don't know how many iterations we have to move. So for these variable x1 variable, we have to first reach to the x2 variable. So every time we have to increment the value plus 1. Okay, so for these x value it is actually greater than, and okay, so greater than like the highest maximum of y value x, uh, y2 value, because that is actually the second value, right? So we have to greater than or equal to, so that we can simply here after writing values, but here in mathematics we can simply differentiate the y1 and the y2. Then we can get how many operations will it take. Okay, so from here we have to find the x value also, that we have to find its difference. Okay, so if it is possible, okay. What if the y value is actually the minus, 5 minus 4? That's what we are doing, right? So if y1 is actually the 3, so 3 minus 4, it may get negative. So whenever this is actually negative, we should directly print 0. And so you have that test case minus 1. You have that test case also. So, so which is this one, minus 2, minus 1, 1, 1. So from these intuition, let us follow these intuition blindly. Okay, so the initial point is minus 3 comma 2. Minus 3 comma 2. What is the point? The point is present actually here. So let us say minus 3 comma 2. Minus 3 comma 2. Okay, so minus 3 comma 2. After that, we can go to the point minus 3 comma 2. Okay, the same point. We are actually present at the same destination. So we don't need to make a single move. The answer is 0. And minus 2, minus 1, 1, 1. So minus 2, minus 1, 1, 1 is like minus 2, minus 2, minus 1. It actually present here. So minus 2, comma, minus 1 stays at here. And we have to go to the point 1, comma 1. 1, comma 1. Okay, we go to the point. So here, this is x1 and this is y1. We have to find the difference between the y1 and y2 and y1. We are finding difference, right? So here 1 minus minus, so plus, so the difference of this one and this one, which is equal to, wait. y1 plus y2 plus y1, y2 minus y1. We have to differentiate, right? So here, we are actually 0 minus 5 minus 0. So 5 into y difference value. 5 minus 0. Here also same. 5 minus 0. So the value is 2. Okay. The value is 2. Minus 1, 0, 1. Okay. It's quite simple to understand. After that, now this exposition is okay. Now for the y place, we have to find the same y in the same conditions, y2 minus of minus, so plus 2, which is actually 3. So here the x change between these x is actually 3, and the original change of x, what is that? Um, Here the original value of x that we want to change is actually equal to 1 again. Okay, 1 comma 1. So here, what is that? Minus 2 comma minus 2 comma minus 1. So from here to here. So the difference between the y's is actually equal to 2, and the difference between the x is actually equal to 3. Okay. So from that 3 comma 2, because that is actually 2, right? So we are having point 3 comma 2. Our destination point is actually 1 minus 1 comma 1. Okay. No, we are not how to directly go to the destination. How to find the destination maximum. Like if minus 1 not escape from that place to, in order to make a move from minus 1 comma minus 2 comma minus 1. What is the biggest value here? So minus 1, minus 1 is the biggest value here, right? No, no, no. This is just make it worse. Uh, let's just build a code for it first. Uh, uh, oh yes, this also accepted the previous one. Okay. So what we have to do? Coins. Yeah. Smart coins. It's about working with master. Okay, working master. So they have to read. They have to read A, B, C, and D. Four ways. So A, B, C, D. So we have to read all of A, B, and C and D. Okay. Now we have values uh, from A to D. So first we need to find the difference of y, which is actually equal to D minus B. Sorry, it gives the difference between them. After finding the difference, we have to find what we are getting difference as actually equal to minus 1, like less than 0, or then we are not performing the operation, right? Less than 0, then we are not able to perform the operation. So we just have to write the test case answer whenever the difference is actually difference of y is actually less than 0, then we should print it's not possible minus 1, right? And after that we don't need to continue this code. Okay. Yes, but if it is not, we have to find the difference between the x values also. So the difference between the x values. So in difference between x values is also the difference between the y values is actually equal to, like y values is actually equal to the like x value difference. So we are actually changing that x value, right? So x value is equal to difference between the y value plus x value, right? So after changing the difference, we have to find the difference of these x values. Like this x value is like the value like a value. Here x represents the value, and now here we have to find the difference of the values on the x-axis, which are belong to x-axis. So for that, difference of x is actually equal to a minus difference of c. Okay, and here also, uh, so we are actually finding the difference between the a and c. So like x1 and x2. So like x2 and x1. Okay, so as this is the code for that problem. It's a kind of tricky one. So we have to understand the test cases. So here, whenever we are standing at position 0, comma 0, uh, we have to find the highest possibility, like uh, the top that we have to. Okay, this is the initial position. From that initial position, here we have to find the maximum top that we can reach, but it's not our answer. Like suppose in a graph, if I say this is 0.0, and instead of directly we can point, right, this is point, this is m, and this is n, and this is m. We can directly point out like this is n comma m. But for like for a computer program, it won't actually find this is n and this is m. It has to use any such algorithm to find this n comma m position. Okay, understand? So for the such algorithm, so as it is stand here, it will go from first here, or here, or here, or from here, here, here. It has to do all the possible touch cases until it reaches the destination. This is the way it follows, which takes like 2 power more than n time complexity, right? So but here we just have a technique. Instead of directly blindly perform the iteration operation, we are just going to the maximum height that we can go. So how can you obtain the maximum height that we can go? It's depending upon the options, like depending upon the final value. So here x1 and uh, y1 and x2 and y2. So here x1 comma y1 is actually the initial positions, definitely, and x2 comma y2 is actually the final positions. So final positions have the height y2 which is greater than the y1. We can't say that it is always greater than the y1, but it greater than the y1. So first we have to go to that y2 position, and with its corresponding x2 position. So now here this is our final position, and from here to the current x2 position, how many steps we are taking? How many steps means is nothing but the difference of between the points. So here in order to go to the top of 5, I have to take the steps from y2 minus y1, that is 5 steps. I have to take 5 steps in order to go from 0 comma 0 to actually x is not actually find x comma uh, like blindly say first we have to go to y comma y point. So here first x is actually equal to y. So after going to that point, here we have to find the x value. So that what here we find the difference of y value. We got it. And if the difference is actually less than 0, the answer is minus 1. Do we have any output like that? 1 2 3 1 2 3. Here minus 1, and this is minus 1. So here x1 is equal to minus 1 and x2 is also equal to 1. So the difference of them, which is nothing but y2 minus y1. So initially it is not actually greater less than 0. So this is not activated. But whenever we get a test case like uh, y1 difference of y is actually less than 0, so 5 minus 1, what if we can get like 5 minus 1 is actually equal to 4? What if minus 5 plus 1, the answer is equal to difference is minus 4? So for this we can return so minus 1, it won't possible. So because it was taken from the constants like minus 10 to the power of 18 to 10 to the power of 18, which doesn't may include the all the coordinates, the points, right? So after that, so yes, we have different difference of y. So we have to add that difference. So this is add the difference to the answer. Take a answer variable, add the difference to the answer, and after that find how many steps we have to take to reach the destination of x. Actually this is the destination of y, where we are in initial step destination of y. So how many steps we have to take to reach the destination of x, that's the point here. So for that we need to know what is this value. This is the value which you can get where you can add the difference of y to the initial value of x. So here x1 becomes x1 plus difference of y. So that's what here. You can completely understand for the next test case, I think. And so after you get it, you can perform the difference of x operation. So which is equal to x2 minus x1. So actually this is the x2 and this is the x1. So here it is always less than 0. See here x2 and this is x1. X1 is actually greater than x2, right? So it is always less than. So when difference is actually greater than 0, then we have to do the opposite operation. So we have to print -1. Otherwise, we have to uh, take the absolute value of that difference and add it to the answer variable, and we have to return. So here 5 minus 1, which is equal to 5 minus what is the difference here? 4. 5 minus 4, which is equal to 1. But we are not performing that way. So 4 minus 5, which is equal to -1. -1 is actually not greater than 0. So that's why we have to take only the 1 and we have to add that to, we can get answer 6. So let us observe the next test case, which is equal to the point is initial point is -1 comma 0 and the destination point is -1 comma 2. So when we perform, the highest point is actually 2. So you can go on blindly point out the 2 comma 2 point. Okay, so now we are at 2 comma 2 point, and the how the x value is changes. Initial x1 value changes. Initial x1 value changes, like x1 is equal to we have to add the difference. So that is difference is equal to 2. So 2 plus x1, which is actually equal to 1. So now this is not the point where you're supposed to be there, bro. This is the point where you're supposed to be there. Okay, now this is where I am here. So this is x1 and y1. X1, actually not the x1 and y1. This is the point where we have to there before reaching to the destination, and this is the destination. This is the destination, -1 comma 2. So now the y difference parts is actually 2. I'm adding to the answer variable, and like, so now difference between the uh, x positions. So here it is equal to 1. So and this is x2, right? So x2 minus x2 minus x1. X1 is here it equal to -1. X2 minus x1, which is actually -2. So we have to take the mod of that value. So that is equal to +2. So 2 plus 2 is equal to 4. So 4 is the answer there. I hope you understand this problem. Uh, it's even, I think it's take a long time to even understand the intuition behind it. At first, I have to do the iteration process. I have to use the for loops in order to find the current position, the exact position. I think even if we can do, it won't accept it. It takes a lot of time to. It take a lot of time to submit. Is that iteration process? Okay, so have okay. I hope you understand this video. Yeah, and if you have any doubt, just comment. I will try to explain. Thank you, guys.